It's 5 o'clock and it's the graveyard shift. So I'm not intending to keep you here for a full hour and a half, but I do want to give you quality for your time. So I'm going to show you what I can, and hopefully that you will benefit by this. But I'm not going to waste unnecessary time. Now, this class was initially planned or designed to be a lab. So you'll see on the handouts there's actually a data set with a PDF that you can download with steps to follow, and that was actually based on the original lab. So I decided when they changed it to a lecture at the last minute, I'll keep it there. You can still go and download that and go through those exercises. And that will also help you and benefit you. So what this lecture is going to be about, what I'm going to explain, is using AutoCAD Raster Design to be able to convert raster data to vector data. But we'll get to that in a few seconds. I just want to find out a bit more about you guys. Just put your hand up if you fall into the category. How many civil engineers? Structural engineers? Architects? Okay, CAD operators? All right. Okay, my name is Chris Foster. I'm from South Africa, so excuse my accent. If you guys don't understand me, just stop me and let me know, but I'll try to be as clear as possible. Also, English is not my first language, so my grammar isn't always perfect, but just try and bear with me. I work for a company called Procon. We develop structural analysis software, but we also integrate our software with Autodesk software such as AutoCAD and then Revit as well. We're also a reseller, an Autodesk reseller in South Africa, so we also sell Autodesk software, and then we provide support and training on the software. All right. Okay, all right, so I've covered that. I'm a technical consultant, just a bit about my background, but I'm also used to be a structural detailer working for various engineering firms in South Africa. I've been playing around or fooling around with programming for the last couple of years, and eventually it became a job and a professional job as well. So, and then that's how I found myself with Procon, with the development of software. All right, and then just a quick class summary, basically what we will cover in this class. I'm going to show you how to use AutoCAD Raster Design on AutoCAD 2013, but obviously you can also use this on any other flavor of AutoCAD to convert poor quality scan images to intelligent AutoCAD entities. Right. You will learn to insert, optimize, and convert these images using the vector raster-to-vector data. I will also talk a little bit about OCR, or text recognition, converting raster text into vector text. All right, and that's just something to wake everybody up. Right, how many of you is familiar with a drawing board? Right. Okay, the learning objectives of this class. All right, so I'm going to explain the three main image types using AutoCAD Raster Design. All right, so when using the software, when you install AutoCAD Raster Design, it's something that installs on top of AutoCAD, and it will actually create a new ribbon item in AutoCAD where you can have access to the Raster Design commands and features. And when we use Raster Design, there are three main types of images that we use to optimize the raster information before we can actually start vectorizing this information. So one of our objectives is understanding and knowing what these three image types are, and then be able to work with them. We'll then also optimize and edit raster images for vectorization. So it's not just a one-click stop where you click a button and convert a PDF to a DXF file. I know those type of software packages exist. How many of you have tried that? And was it successful? Yeah, it's crap, because it's impossible. It's physically impossible to just convert raster data directly to CAD data. Right, so something has to happen. There needs to be some user interface or some interference or input from the user to be able to optimize the raster data before you can then use the tools to create vector data from this. And that is what raster design is about. So it's not a one-click button and it quickly converts everything to raster data. It's a process. All right, so that would be the second objective, understanding how to use the tools in raster design to be able to optimize these images before we start vectorizing them. And then, of course, convert the raster data after it's been optimized to vector data using the tools provided in AutoCAD Raster Design. And then finally, the last objective, I'll also show you how to use the text recognition functions in raster design. So not just creating lines and circles, but also to be able to recognize text. Okay, we'll start off with the three main image types. First one that you'll see there is the bitonal image. So I've tried to arrange these in order of how many bits per pixel they actually use. Now, bitonal images is the most basic type of image that you use in AutoCAD Raster Design, and this is the one that you want to work with. There's a sample of an image that is actually a screenshot of a bitonal image, and it's basically, in this case, a two-color image. And if you look at the properties of that image, just selecting the image and then opening up your standard AutoCAD properties, you'll see the raster information. And it will show you by color type what the color type is, and it will actually say bitonal. But you can also see the color depth is 1 bit per pixel. All right, and those are bitonal images. These are the ones you want to work with. So normally you would receive a grayscale image or a full color image that can vary in bits per pixel, but what you want to end up with before you can actually work with this information is the bitonal image. All right. As I've mentioned, the other one is a grayscale image. Now, you all know what that is. Those will be varying colors from black to white. And these are also, they are 8 bits per pixel. That's the color depth of the grayscale images. All right. And then finally, we've got our standard color images where the color depth in this case was 32 bits per pixel, but that can also vary. Now, as I've mentioned, the most important thing is we want to end up with those bitonal images. So in raster design, we would use tools and features to take whatever format of image that we've got, and the chances that you receive a bitonal image is the odds are very low. So you would take the grayscale, the color image, and then convert this firstly into a bitonal image. All right. Now, just to explain to you, the presentation that I've got will also reference the same files and exercises that I've included in the handout. And as I mentioned, that was actually designed for a lab class. But I'm going to use those same images and explain a bit more in depth how they work and what's actually going on behind the scenes instead of just telling you to click here and click there. So I've used two images in this class. The first one is a perfect world scenario image. So this is one of high quality, scanned in a high quality image. It was actually created using a package like AutoCAD and printed and then scanned in back into high quality. And then I'm going to use this to convert it to vector data. But I also told you that this class is going to be about converting poor quality images as well. So this is the one image in the perfect world scenario. The next one I've got is one that is... does anybody recognize this? Okay, I thought it was appropriate. So this one... this one is actually quite a low quality PDF, which you can't use directly in raster design, so I had to find a converter to convert the PDF image to a PNG format. But you still sit with something that is extremely pixelated. All right, this image actually was also a scan, in fact, the one that I've received. So we'll also be working with an image of a lower quality type, such as this one. Right, now the first thing we need to do is to insert the image into the model, and we're going to do this by using the tools from the raster design menu. And this brings us to our first objective: optimize and edit raster images for vectorization. All right, now inserting the image is quite simple. At the top left of the raster design ribbon, I'll show you a bit about that as soon as I'm finished with this objective. You'll have an insert button. And you can use this and insert almost any type of image that you can think of. TIFF files, georeference TIFF images, JPEGs, bitmaps, PNG files, it doesn't matter, Mr. SID files even. So you can insert almost any type of image. But you have an option on the insert dialog box, insert options. Do you just want to do a quick insert? In other words, it's very much similar as you would insert images using AutoCAD without raster design. You'll just insert it, indicate the point, and then set the scale for the image. Or you can do this by using an insertion wizard. Now, the insertion wizard actually allows you to do some basic correlation on the image while you're inserting the image. So it can save you a couple of steps. These are basic correlations, so you won't be able to scale the image in different X and Y values, or be able to create a bias operations or anything like that. You'll basically be allowed to insert it, add a fixed scale to it, and a rotation. But that saves you a couple of steps, so I like using the insertion wizard. And you're also able to see what happens when you insert the image. So if I use the insertion wizard and I inserted this image called sample1.png, it first gives me a dialog box indicating what the current values of this image is. And as you can see, when I inserted this image, it's rotated 90 degrees. Obviously, I would like it to be rotated 0 degrees. Right, so it gives me the current properties of the image. I'm not able to change that. Those are fixed values of the image. But directly after I've done that, if I click on the next button, then I've got the option or the opportunity to go and change some of these correlation values, switch the rotation to 90, change the scale if I wanted to, and then as you can see, the orientation of the image is the way that I would expect it to be. Right, so fairly simple, just insert, follow the steps, and insert the image. Alternatively, you can also insert the image without using the insertion wizard and select the image in AutoCAD and use standard AutoCAD features like rotate to rotate the image into the correct position. All right, that's the first step, inserting the image. The next step is to start cleaning this image or preparing this image for vectorization. Vectorization is actually the last step. We need to prepare this image, remove all of the clutter and small little pixels or dust or any unclear parts of this image. And apart from that, we also have to go and fix this image. Sometimes, depending on the quality of this image, you might find that you've got gaps where there was supposed to be a continuous line. It might be broken up, or some objects might be scaled differently across the sheet. Let's say you've got a piece of paper that's 20 years old and this thing's a bit rubbly and it's had a couple of coffee stains, etc. You know, then when you're scanning this image, you might find that you've got different scales along this image. So you can't just use a set of or a standard, a specific scale to be able to rectify that. So we call that rubber sheeting, by the way. But these tools we are going to use to try and get this image as perfect or as close as perfect as possible before we start vectorizing it. So the first one, or the first phase, I call cleaning the image, and that's removing speckles and things like that. So the first step with the cleaning phase is what I normally like to do is to just invert the image if it's in black and white. Otherwise, if it's not in black and white, I would then change it to a grayscale image. Now, I'll show you directly after this objective how to do that. It's quite simple. But depending on the background of your AutoCAD, it's just easier on the eyes to have the same background on the image as you would have in AutoCAD. Now, I prefer working with a black background in AutoCAD when I'm doing personal work or when I'm sitting behind the desk, but once I start presenting, I find it's easier using a white background just for the visibility on a screen. So in the case where I use a black background, then obviously I'd like to go and invert these colors so that it actually starts blending in with my model space. And it's just easier then to identify objects and see what's going on. So it's quite simple to invert on the raster ribbon. You'll see that there's a cleanup drop down, and you can use this and just select invert and basically invert the colors. Despeckle is one of my favorite tools, and in this case I showed you the image with the lesser quality which contains speckles. Now this happens due to objects that might be on the piece of paper when it's scanned, like coffee stains or marks that have been accumulating over years, or whatever the case might be. And when you start converting this to vector data, you don't want this information to be on your raster, so you want to go and clear that up. Now basically what despeckle allows you to do is, once you use the command, it asks you to go and select a speckle, a sample speckle in the drawing. So it's going to ask you to draw a window, basically. And this is going to indicate the size of the speckle, and it's going to then run through either a selection on the raster, or the whole raster image. You've got a choice by using parameters in the command for the area to analyze, and it will go and remove speckles of a similar size that it finds. So these will be isolated little pixels residing on the image. All right. The next one is to de-skew, and this is quite a common one. As you saw with my lesser quality image, this one is obviously scanned in, and it wasn't scanned perfectly. It was actually a little bit skew. And the de-skew command works very much similar to what the alignment tool in AutoCAD works. Right. So when you select de-skew, it will ask you to specify a base point. It will ask you in the X direction to specify an existing point. And I want to just stop there and also show you that in raster design, you've got something called raster snaps. So when we specify base points and reference points in order to align the X and Y borders of this image, we can actually snap to rasters within the image. Now, if you look at the ribbon that I've got here, this is the raster tools. This is what you get when you install AutoCAD Raster Design. And the tools I was talking about cleaning up is on this edit panel. You'll see on the edit panel the cleanup drop-down. There is invert, there's my despeckle, and there is the de-skew tool that I'm referring to now. But you've also got something called raster snap. Now you can switch raster snap on and off, very similar to what you would do with standard snaps in AutoCAD. But what this allows you to do is to actually select or snap to endpoints, intersections, etc. directly in the raster image. Now this is quite amazing if you think about it. This basically gives you very basic CAD functionality while you are actually still working with a raster. Now at this stage, we are still just working with a raster, so you can actually compare the functions that we're doing here similar to working in something like Paint, for instance. All right, so we're still just working with the raster image. We're removing pixels. We're going to add some pixels later on to be able to optimize this drawing. But we're still just basically working with the raster image. All right. Some additional cleanup tools that I'll just mention. There's a touch-up tool which you can use to add information. As I've mentioned, you might have a line that was supposed to be a continuous line, and suddenly there's a gap in this line because of the scan quality or whatever the case might be, and you would want to go and fix this up. Later on, when we create AutoCAD primitive objects, like lines, for instance, from the raster data, we want to be able to trace these lines automatically and convert them into raster data. Now, once it doesn't see a continuous path where it can create a line, it's going to create two separate entities, and later on, you will have to go and join them in AutoCAD or whatever the case might be. But you can save yourself a couple of steps by fixing up the raster beforehand. So we can use the touch-up tool for this. This basically allows you to add pixel information to the model. So you will see what I've actually got here in this model is I've switched on my raster snaps, so I want to be able to snap to the endpoints of where I want to add the pixels. Using the touch-up tools, I specify, do I want to use a circular type of brush, do I want to use a rectangular brush, whatever the case might be, and then what the size of this brush should be, and then exactly where I'm going to add those pixels. Quite simple, basic raster editing. And that is what the end result looks like. Right, so that's what I zoomed into a specific area where a continuous raster line was actually broken, and after the touch-up, that is what it looks like. So quite simple. This also saves this back into the image. All right, so whatever you are doing here is directly manipulating and changing the raster image that you originally inserted into your drawing. Another one I want to talk about is the bias tool. This allows you to create different X and Y scaling to an image, which you might encounter or find that you would require quite a lot when working with lesser quality images. Now in this case, you can see that I've got sort of a cropped or a scaled view where you can clearly see the X scale and the Y scale doesn't really correspond. For instance, I've got, we work with a metric system, so I'm going to referring to millimeters and meters. So you can see I've got a dimension there on the scan image of 4,000 millimeters. Now if you just look at the vertical dimension there of 2,000 millimeters, obviously this image is not in a proportional scale. All right, so I'm going to use the bias tool to fix this. And again, these commands are very much based on the basic AutoCAD commands. So if you've used move, copy, rotate, draw a line, deleted objects, used the alignment tools in AutoCAD, then it's very simple and quick and easy to use these tools. Always follow the command line as well. It will exactly explain what is required from the user. So it's going to ask me to specify a reference point. I'll be stretching in the one direction, the X direction first, and then in the opposite direction. And using the bias tool, that is the end result that I got. what I actually did, and this is in the handout, you'll see it there, is what I actually did here is I created a couple of AutoCAD temporary lines, and I spaced them using the dimensions I've got in the raster image. So what I did is I drew one line. I actually used the raster snap tool to be able to position that vertical line directly on the grid line that I've got in the image. I then offsetted that line 4,000 millimeters, and I did the same for the opposite direction. And that I could use as a base and a reference. Right, so I've got a common base point, and then I was able to use the bias tool to go and line up these different points within the model or in this raster to be able to get it scaled proportionally. So now I've got an image that is still just a bitonal image, but already it's scaled to proportion, and it's been de-skewed as well. Right. There's some additional cleanup tools that I'm going to talk about. It's quite simple tools. It's basically removing different objects. So you'll see to remove unwanted regions, on the edit panel there's a remove drop-down with many various different options on how to remove pixels. You can draw polylines and remove a region defined by a polyline, or you can use circles, or you can use rectangles, whatever the case might be and what you would prefer. You can also use a smart pick, which is something that's going to try and identify continuous lines or connected elements and then automatically delete that as well. But I would suggest playing around with them and see how they work. It will also differ from the different quality types of images or scanned images, raster images that you've got. All right. The next one is changing, the most important part is changing the color depth of this image to a bitonal image. Now, in raster design, we've got objects called REM objects. Now, we're going to get to that in the next bit. But to be able to use these REM objects, those are raster entity manipulation objects, we need to work with a bitonal image. Right. So in the end, after we've done all of our work on the image, removed all of the speckles, scaled it proportionally, etc., we need to convert this image to a 1-bit per pixel image, and that's the bitonal image. So this is very important. If you don't do this, the rest won't work. Now, to do this is quite simple, but a little bit confusing at first, because you have to change this image to a bitonal image, and if you click on the process image drop-down, you immediately see bitonal filters, and if you just have a look at it for the first time, you'd assume that's where you need to click, but it's not. You need to click on change the color depth. Right. Once you click on the color depth, you'll have two options, either grayscale or bitonal. You just select bitonal. All right. And that immediately converts this image to a bitonal image. Now, this brings us to the raster entity manipulation. Raster entity manipulation is basically something that creates AutoCAD primitives by retracing the original pixels in a defined area. And then we can manipulate those entities, the raster entity manipulation, I'll refer to it as REM. Not the band. But anyway, so you can use that as standard lines with grip points where you can reposition those start and end points, and it will actually then recreate the raster data according to those entities. All right. Okay, so as I've mentioned, the REM objects can only be used with bitonal images. It creates advanced raster entities enabling CAD-like modifications. That's basically what I try to explain. So it's going to retrace the raster pixels and then create basic primitives on top of those. And we can manipulate the raster data in the background by moving the REM objects. Now, as I go along, you'll see why that is important. We can also use the REM objects to trace certain parts of the raster data and then just press delete and move that or remove that or mirror or copy or whatever the case might be. And then it can also trace and replace existing pixels. I'm going to explain that. But using these REM objects, just as awesome as it is to be able to snap to endpoints or intersections on raster entities, we can also use functions like offset, fillet, knife, etc. with directly in the raster. So long before we start creating the vector data, we can already use these basic tools within the raster information by enabling or utilizing the REM objects. Now, to do this is quite easy. There are two methods or two basic areas where you would go to be able to use the REM objects. The first one is the create region, and directly next to it you'll see enhanced region. So they gave you quite a couple of different ways to be able to create these regions, and personally I find that I've only used 2 in all of the exercises that I've ever done. But anyways, creating regions is basically defining a window by specifying either a polygonal area, rectangular, diagonal, circular, whatever the case might be. And then I'll get to the enhanced area regions in a second. Now, what this slide here shows is what happens when I used the diagonal tool to define an area where I want to create the REM region. Now, in your settings in Raster Design, I'll show that to you as well, you are able to go and decide which color should the area be filled with when it creates these REM objects. Obviously, if we're using bitonal images, we're going to have basically white lines and a black background, or the other way around. All right, so we can use any other color to indicate other objects, like, for instance, and by default, red would indicate the areas that is created by the REM objects. Now, what I've done is I've just used the simple create region, used the diagonal tool, created a window, and as you can see, where I created this diagonal window, it gives me a red border on the outline to indicate where this area is. And everything within this border has been retraced by these REM objects, and they display red. All right, so that's my REM region. And even the text, you'll see that it actually also cut the text. It didn't try to recognize text or any closed loops and any lines. I've got a break line here at the top. It didn't recognize that that line is actually continuing or anything like that. It just used the area that I specified. All right, so those are using standard regions. Once we start using the enhanced regions, and I'm not going to go through all of them, but I will explain the basic principle. We've got many different options of how to have a much more clever way to identify continuous elements or crossing elements or boxed elements. All right, much as what you would do with cross or box selections in AutoCAD. If you've got a bunch of lines in a certain area and you use a cross or box selection, for instance, in a box selection, it will only include the objects that are completely within the selection. Otherwise, in a crossing selection, everything that's crosses is selected. So we can use the same sort of functionality when creating the REM objects. The first one I used here was Smart Window, and basically what this does, you'll see there is the window that I created. So within this red area, that white square is the window that I created using Smart Window, and that is my selection. All right. So even though the window crosses those horizontal lines, it obviously didn't include them. This only included the objects that was in that selection, like a box selection. You can also use cross selection. You can use Smart Pick, where it tries to identify a continuous line or element that is continuous. Now, working with these REM objects, once you've created them, you can take those areas or regions and you can move and copy them as you like. Just to skip one slide back, if I were to select that red rectangle, which defines the REM region, I can move that to a different location. I can delete it. I can scale it. I can rotate it, whatever I'd like to do. And that will directly alter the raster image in the background. So it's directly connected to that raster data. All right. Now, from the REM objects, we also want to create primitives, REM primitives. And these objects are basically, what they do is they take the REM regions, they create an AutoCAD primitive on top of that, allowing us to manipulate that information. And again, once we change the REM region or those objects, it directly affects the raster image in the background. We then merge this back into the current raster that we've got. Now, I'm going to show you a sample of that in my the image with the lesser quality, and how this would actually help us and why you would want to do this. Now, what I've done is you'll see that I've zoomed into one of those cocktail glasses in the famous drawing. And what I wanted to do is I wanted to first just indicate how I can remove certain segments using the selections of the REM objects. So what I've done is I've created a region, just you can use any one of them. I've created a window selection, and I've selected that region and simply pressed delete, and obviously that is removed from the raster image. So it's quite simple. And then there were some bits and pieces that was left of the original information that I wanted to go and delete as well. And here I had to use a Smart Window to be able not to select the objects that is around the one that I specifically wanted to delete. So by drawing a window, a small window in that area, I was able to select it and only remove that part of the raster image. Now, once we've optimized these REM objects, we can start retracing them with REM primitives. These aren't real vector data yet, but it's getting a lot closer. Right, so once we start creating primitives, or click on the primitive drop-down, you've got 3 basic options or object types: lines, circles, and arcs. All right, those are the 3 objects that you can work with REM primitives. There is a smart pick, which will actually then, the program will try to decide for you what object to use in which situation. And then there's something that says, from existing vector. And that doesn't make a lot of sense. Why would you want to take an existing vector, take it to an REM, and then back to a vector? And the reason for that is actually, sometimes you want to create some temporary lines for yourself on top of the raster. And you want those AutoCAD vector lines to be able to directly manipulate the raster image again. And that's why you would do this. All right. Okay. Moving on to the next slide, performing REM editing. And what I've done here is I've taken that same cocktail glass and I've moved to the stem or the handle of this glass. And I wanted to show how I can optimize this image in order to create a perfect vectorization result. Now, as you can see, on the left-hand side of this raster image and the right-hand side, the image doesn't look very perfect. You can also see where I've got small little fillets or corners in the original image. It doesn't match the opposite side. And this is obviously sort of a profile or a section, elevated section view of the glass. And it should be exactly symmetrical if I had to draw a line down the center of that handle. All right, and it's currently not. So if I convert this to vector data, it's not going to be something of much use. It will be inaccurate data. So I want to take this image, improve on the existing raster information before I start vectorizing this. So this is what I'm going to do. I start tracing those objects by creating primitives. So it's very simple. You click on the Create Primitives drop-down, and you can. I used the Smart Pick here. It actually worked quite well. So I just did Smart Pick and I start tracing these elements. And what I then did is I used my REM regions, and I selected some of the regions, and I deleted all of the pixels on the right-hand side of my temporary center line that I wanted to use. And that is basically what I ended up with. So I've got 1/2 of that profile that I want to work with. And basically, once this has been optimized, I can then mirror this and my raster images of a much higher quality. That's exactly what I've done. I started using the fillet and trim commands within Raster Design, and that is what I ended up with. And this information, once I've done this with these REM objects, they're still in red, so they represent the REM objects. You just right-click on the drawing and you select Merge to Raster Image, and it will actually take that back and put it back into raster data. All right, so, or you can do this from the ribbon as well. There's the option to merge that back into the raster image and look at the quality of that. It's still a raster image, but a much higher quality than what I started off with. All right. So as you can start to see, this is actually quite a lengthy process. All right, it's not a quick stop shop. So what you have to consider before attempting to convert your existing raster images to vector data is, why do you want to do this? What is the purpose of this? How much time is it going to save you? Would it be better to just redraw it from scratch, or whatever the case might be? And then what the quality of your existing data is. So it is possible to enhance these images, and if you're never going to use it again, why convert it to vector data? Maybe you can leave it as it is, as a higher quality raster image, and print out whatever you need. But if you've got something that is a good quality scan and is something that you can really use, then obviously it will save you all of these steps manipulating the existing raster information. All right. And that brings us to the next step. But before we get to the next objective, I just want to show you where all of these tools are. Back in Raster Design, these are the REM tools, and I just want to show you, working with the primitives, once I've created the regions or enhanced regions, I can then also create the primitives from the raster image. There's line, circle, and arc. Once I've created those, I can use basic tools, as I've mentioned: knife, smooth, trim, cut, fillet, offset, etc. So those are where those tools are. The color that I'm using for the REM objects, I can also go and change. By default, it's set to red, but you can go and change that. Alternatively, if you click on the options button, you can go and directly access all of Raster Design's options and colors that you're going to use by default, etc. All right. That brings us to our next objective. Convert raster data to vector data using this raster that we've created now. All right, now just to the right of the REM objects, we get the vectorization and text recognition panel. Now, as you will see, as I've worked along so far, we actually started on the left of the ribbon, and the whole workflow is we just moved towards the right. So on the complete left of the ribbon, we had insert. We used that to insert the image. Then we went to the edit panel, which was the next step to do our basic robust correlation and fixing and cleaning up of this image. Then we went to a bit more advanced image editing, which was the REM objects, and now we're moving to the rightmost panel. So you start from the left and you work your way towards the right. All right. But before we start converting the raster information to vector, we need to go and set up a couple of properties. Now, what the program will try to do is, we've got two basic options. We can use followers or primitives. Followers is the one I like most. This will try and identify a logical continuous path to create a line arc or whatever, polyline, and then replace that by vector information. But obviously when it does that, sometimes you would have pixels that doesn't line up perfectly, or it might have small gaps in the raster if you haven't fixed them, or whatever the case might be. And we need to go and tell the software what to do when it encounters these problems, or what happens when you encounter an intersection with a crossing raster information that represents a line, for instance. So we can go and specify these options. First of all, we've got a removal method. So whenever it identifies raster information and replaces that by vector data, we want the original raster pixels to be deleted and removed from the image and completely replaced. By default, that's the way it works, but you can go and change the setup so that you can actually, you can say none, and then it will actually keep the original raster information as well. I don't like doing that because I want to see actually the areas that I've already completed, and as I progress along the image, what is actually happening. Then we've got a rub or a crop width. And that is basically by default set to 1, and this works in pixels. So it's going to look, when it creates a raster or a vector information on top of the raster information, the area that it has to delete next to those objects. All right, sometimes you might have clusters of pixels that is actually still part of one continuous line. So you might have to play around with these settings depending on the quality, again, of the raster image. Right. And if all of this has been set up, and if your raster image was optimized properly, then these functions should work quite perfectly. Right. We've got a jump length in pixels again, so when it comes to a certain point where it gets a gap in a certain element and it needs to decide whether it's going to continue creating an element along a path or whether it's an actual stop of that element, that is going to be a jump length. Intersection stop, this is a drop-down with options where we can decide what to do. Do you want to stop at intersections? Do you want to continue? But I'm going to talk a little bit more about that in the next few slides. So once you have set up these parameters, you can now start using either followers or primitives to then replace your raster data with vector data. I'm going to show you how both works, but as I mentioned, I like the followers the most. It's the simplest one, and it does the most work. Now, using followers, you've got three options. There's a polyline follower. Then you've got a contour follower and a 3D polyline follower, which might sound weird because images are 2D, so how can you use 3D polyline followers? Basically, what the 3D polyline follower does is it will try to trace characteristic points on the image. And once it identifies a characteristic point, it will ask you to then specify, so it will prompt you to specify a change in elevation. So that'll either be a positive or a negative value. All right. You won't be able to, let's say, convert a 3D image of a motorbike by using the 3D polyline follower. You know, it won't go into that much detail, but basic functions you can use. Let's say you've got a high quality orthogonal view of something. You know, you might be able to use the 3D followers to be able to at least greatly assist you in converting that into raster data. But the ones we're going to look at now is polyline follower and contour follower. Right, specifically polyline follower. And basically how this works is you click on the command and it's going to ask you to select somewhere within the raster image on a raster line or raster circle that you want to convert, and it's going to try and identify logical path and then replace that by vector information. That's exactly what I've done here, and I've used this break line that I've got in my existing image as a sample. Just a tip, if you want to write this down, using the raster snaps to snap to an endpoint of a raster is a good idea when doing this, because you would learn to start from one point and run through in a certain direction all the way to the end. All right, so that's basically what I've done here, and you'll see once I do that, it actually retraces or traces the original line or the information with a blue line indicating this is the line that is picked up, and I can then accept this or reject that. And this is what happened. The information you see at the top here is actually raster data. Using the polyline follower, it converted it directly into a polyline. I then selected the polyline to show you what actually happened here. Now, the purpose of this break line is obviously to show that whatever elements is on the one side is actually continuous, but we don't show it in this drawing. In this case, it was a column. Now, what happens is those column lines actually intersects with the break line, which is what it's supposed to do. But when I create the polyline, it picked up those intersections and created polyline vertices at those intersecting points. Okay. Now, there's nothing wrong with that, but I prefer having cleaner polylines with as little as possible vertices, and only those that are required. And this is why I started using the knife tool. Remember, I talked about the knife tool with the REM objects. Now, using the knife tool, what I did, and it's almost impossible to see here, but what I did is I zoomed in and I used the knife tool just to make a small split between the lines that represent the column and the actual break line. And I used exactly the same command again. I used the polyline follower, and this time it created a perfect polyline, exactly replacing those raster information with vector information. Okay. Those were using followers. You can also use on the drop-down directly next to the followers, you'll get primitives, and you can use the same method with a bit more user input required depending on the object you want to create, but you can then create lines, polylines, rectangles, circles, and arcs. When doing this, it will prompt you on what to do depending on the object you want to create. There'll be prompts and parameters that you can play around with. It will try to identify a direction or a logical path to follow. If it's not able to do that or do so, it's going to prompt the user for a bit more information, and you will have to specify the information as is required. In this case, I just used a simple line to start tracing those columns in the raster image, and you'll see at the top there, that's actually where I clicked, and again, use your raster snaps when doing so, then you know you actually start where you want to start tracing this image. It indicates an arrow to specify direction. Now, I can access the parameters and I can change parameters. I can indicate a new endpoint if I don't like the endpoint that Raster Design has detected for me. All right, and that actually shows the parameters. In the case when creating arcs or circles, you see you've got lots of parameters, and they tend to be a bit more tedious working with arcs or circles, especially if you look at the raster information. Those pixels tend to clutter up a lot more than what they would do in a straight line. So that makes it very difficult sometimes to be able to identify a circle. Like in this case, as I'm showing here, just look at the bottom right section of this slide. You'll actually see what happens to those pixels along a curve. All right, so there's no perfect path to follow, and it's going to prompt you to specify a specific point and to be able to convert it correctly. Okay, that basically covers the vectorization. So it's very simple. The whole vectorization part is actually quite easy. The most work is in getting the image perfect enough for the program to be able to identify the correct geometry to trace. All right, and then I'm going to talk a little bit about using the OCR functions. This is also quite a powerful part of raster design. Again, depending on the quality of the raster image, but you can actually go and set up parameters and then convert raster text to vector or AutoCAD recognizable text. Before we do so, again, it's important to go and specify the correct settings for each project, and it might differ from project to project. For instance, if you just look at the text recognition setup, you'll see on the input, we've got text format, and it's asking, is it machine printed or hand printed? This helps the program to try and identify what these characters should be. So the first step is to try and identify the characters. What it then does is it looks at a dictionary that you specify, try to make sense of these bundle of letters or characters that you've got, and try and put that into a word if it's possible. If it can do so, it helps to further the accuracy of the OCR process. Now you can think of something as simple as the letter B and the number 8. The software has got absolutely no idea in a sentence or in a word, should it be a B or an 8. It's identifying the character. But obviously using a dictionary, it will be able to determine which one is the most obvious choice. Okay, you can also go into this language character set and specify additional characters that you want to try and identify. Also, you can specify what you want to recognize, uppercase, lowercase, numbers, special characters, etc. Then the output, do you want this as AutoCAD text or AutoCAD MText? Doesn't really matter, whatever you prefer. The text height, it will try, if you say automatic, it will try to identify the text height of the raster text. But this can vary along the project. And usually when you create a drawing, you want the same text height throughout your drawing, hopefully. So what you would normally do is you can specify a style height or a specified height of your text. And it will also replace, you've got the option, you see there's a removal method. So it will also replace the raster text with the vectorized text. Mine currently is set to none, and those are the default parameters, but I actually prefer to have it set to rub. In other words, I want to remove the raster information. Then there's an AutoCAD style for the text as well. You can specify a style if you want to, if you've got any styles loaded. If you leave it blank, it will take your current default style. All right, and then basically some additional options for bold, italic, underline, etc. So once those parameters has been specified, you can then just basically select OCR and you go and draw a rectangle. I'll be with you in a second. You can go and draw a rectangle around the text that you want to start to go through the OCR process. Now how this works is in AutoCAD, when you select this text, it won't always necessarily be at orthogonal angles. It might be at a 33-degree angle or whatever the case might be. So you can't just go and draw a rectangle around the text. It needs to also know what the angle of the text is. So you've got 3 points that you have to select. The first point in AutoCAD, this is now on my text bar, but the first point would be at the bottom left of the text. Your second point would be at the bottom right, and that can be at any angle. And once you've selected those 2 points, it will connect it with a straight line, and it's going to ask you to specify the height of that box. And then, obviously, you would just drag that to include the text completely, and hit Enter, and it's going to try and start recognizing it. Yes?
Where do you find that text recognition setup?
Okay. Let me show you. In the same options menu as I had before, you can find that. Or if you go to your OCR drop-down, you'll see at the bottom you've got optical character recognition of the OCR setup. And this is where you'll find that. All right. Okay. All right, so that is basically how the text recognition process works. It's quite simple, it's quite easy to work with. One thing that I have encountered is sometimes when you insert the images and you use the insertion wizard, contradictory to what I said before, it's sometimes, actually when you use correlation there and you rotate the image by 90 degrees, it doesn't pick it up as a straight line, it actually throws the characters below each other. But that's only happened to me ever once. And I was able to fix it by inserting the image and manually rotating it in AutoCAD. Apart from that, it works quite well. You've even got the option to recognize tabulated or table text, right, with the OCR.
Is it? I tried OCR to scan images like 15 years ago, and to train that, it took so much time. It's much easier to just type on top of it in AutoCAD.
You can do that. If that's a quicker route, definitely. It's improved a lot. I've tried various strings of raster text to convert them and see where the pitfalls and the problems are. And it actually recognizes pretty good. Up to a reasonable point, of course. But you've also got an interface. So once it recognizes the text, you can still go and edit that text. So instead of retyping everything, it skips a few steps. It does a few steps for you. It firstly removes the area of where the raster text originally was. It tries to identify it as closely as possible. You can then quickly make a change if you want and click on OK, and there it is. Alternatively, remove the region where this text was and put in M-text or single line text.
Character by character to make sure I got it right.
Yeah. Okay, I'm going to answer questions directly after this, if you guys don't mind. My South African plug, of course, doesn't work in these plugs, so I'm low on battery power. Okay, so if you don't mind, let me just quickly run through this. The class, just looking at the summary, we've got 3 types of images in AutoCAD Raster Design. Those were bitonal, grayscale, and color images. All right, and just quickly running through that. Optimizing raster images using raster design, correlate, edit, REM and REM primitives. Then we convert this information to vector data, and then alternatively we can use OCR Setup to get the end result. This is my company profile. This company I work for, Procon. We create structural analysis software. If you guys would like, please contact me via email. Go to our website for additional information. We've got a YouTube channel as well that you can refer to. We always post tools and tips on this YouTube channel for guys. And then for further information, I've also inserted a link there. You'll find this in the handouts as well for additional and tutorials that you can use on AutoCAD Raster Design provided by Autodesk themselves. I thank you for your patience, and if there's any questions now, I'll be happy to try and answer them.